Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the isometric projections of the combination of the solids. In this problem statement, we have a hexagonal prism of side of base 40 mm and height 60 mm with the right circular cone of base diameter 40 mm and height 50 mm resting on its top such that the axes of both the solids are collinear. So here we need to interpret the types of solids. So the types of solids are the hexagonal prism and then the right circular cone. So the right circular cone indicates that the apex, which is the joining point of the slant generators of the cone, and also the centroid of the base of the cone, that is the center point of the circle of the base of the cone. So the imaginary line joining these 2 points are collinear. So this is what is the meaning of the right circular cone. So we need to understand the dimensions also. For a hexagonal prism, the base edge is measuring 40 mm while the height is measuring 60 mm. And for the circular cone, we have got the base diameter of the cone as 40 mm and the height of the cone as 50 mm. So this is the data that is given to us. So with this data, we need to construct the isometric projections of the combination of these solids. And we should also keep in mind that these solids have their axis collinear. So with this data, let us see how to draft the orthographic and as well as the isometric projections of the combination of these two solids. So now let us select a line of thickness 0.18 mm and then draw a line of any arbitrary length indicating that this is the reference line. Now let us draw the top view of the first solid, which is on the ground. So on the ground lies the hexagonal prism. So now let us go for constructing the hexagonal prism. So let us select a line of thickness 0.50 mm and let us draw the prism. So it is having the base edge as 40 mm and then the first angle being 60 degrees. The next angle is 120 with the base edge measuring 120 40 mm. So the angle is 60 into 2, which is equal to 120. So next again 40 mm is the edge length and the angle is 180 degrees or 60 into 3, followed by the line of length 40 mm and the angle being 60 into 4, which is equal to 240 degrees. And then we'll complete the hexagon by drawing a line of length 40 mm and an angle of minus 60 degrees. So this is the top view of the first solid, which is the hexagonal prism. So in the previous video, we have seen how to draw the hexagon resting on one of its corners. So we'll understand how to draw the hexagon resting on one of its edges here. So there is no condition that it has to be resting on one of its edges or the corners. We can assume any condition. So let me just select the entire hexagon, select the rotate option, ensure the copy is off, select this point and rotate the hexagon in such a way that these 2 points are perpendicular. So now let me just move this hexagon. So let me just place the hexagon here. So this is the top view of the hexagonal prism. And also I need to draw the cone which is resting on the hexagon prism. So if I just move these cursor on the two edges, I'm getting the center point of this hexagonal prism. So from this center point, I need to draw the circle, and that is the top view of the cone. So the top view is nothing but the base of the cone, which is equal to the diameter of 40 mm. So let me go for the smart dimension. So this is 40 mm, and also this edge of the hexagon is measuring 40 mm. So I can just show these two dimensions. So now let me draw the front view. So let me select a line of length 0.13 mm, draw the projection lines from all the corners. So let me just draw a line from the center of the cone and the hexagon, which is common. And from here, I need to draw the axis. So let me select the axis line of thickness 0.13. So first, let me draw the axis of the prism, which is measuring 60 mm. So this is the axis of the prism. On top of this, I need to draw a line of length 50 mm, which is the axis of the cone. So now let me complete the front view. Select a continuous line of thickness 0.50. Let me draw the base of the prism by joining the endpoint of these projection lines, and also the height of this prism is 60 mm. So let me complete this. So 60, and this length is equal to 69.28. So this is the front view of the prism. Since this edge is visible, I'll be covering up this with a visible line like this. So these are the two faces, the rectangular faces of the hexagonal prism, which is visible in the front view. Now I need to draw the front view of the right circular cone. So let me select a line of thickness 0.13 and draw the diameter of the cone. And from the endpoints of the diameter, let me draw the projection lines. Let me use the extend to next option and extend these projection lines to meet the top face of the hexagonal prism. Select the line again of thickness 0.50 mm. So from the end point of the center line, let me connect this to the end point of the projection line from the cone top view. So these are the slant generators of the cone which is visible to the observer in the front view. So this is how we need to draw the combination of the solids wherein we have got a right circular cone placed centrally on the hexagonal prism top face. So these are the combination of the solids whose isometric combination has to be drafted. So here we have got the dimensions of the cone, that is the height of the cone and as well as the height of the prism. Let me select the annotation option and annotate the reference line as x and y and also the reference planes as VP and HP. So with this I complete the first set of drawing, that is the orthographic projection of the combination of solids. So now let me go for the isometric projection. So before we proceed with that, let me ensure that I'm going to cover up this solids in a rectangle or a square so that I can replicate the same in the isometric drawing and then mark these edges. So let me select a line of thickness 0.13. Let me select a line of color blue and then enclose this hexagon in the corresponding rectangle. So this is the height. So let me just enclose this entire hexagon in this rectangle. So this rectangle isometric projections I'll be drawing and I'll be marking these points, say 1, 2, 3, 4, 5 and 6 on the rectangle and complete the hexagon. So that is the procedure that I'll be following. Next, let me select a line of color dark green and enclose this circle. So this will be a square of 40 cross 40. So this is 40 and then this is 40 again, and let me complete the square. So this is the constructions that I require for my isometric projection. So now let me proceed with the isometric projection. Let me select a line of color black of thickness 0.13. Draw the ground or the base line on which the first solid will be resting. So let me go for the distance between. Select this line and this line. So the distance is 80. So I need to construct a rectangle of 80 cross this dimension. Let me measure. So from here till here it is equal to 69.28. So 69.28. So this is the rectangle that I'm going to construct. So let me select the line option again and select the blue color so that it is understood that I'm going to construct this particular rectangle. So from any arbitrary point, draw a line of length 80 mm, which is one side of the rectangle, incline at an angle of 30 degrees, and then next length will be equal to 69.28, incline at an angle of 150 degrees, followed by 80 mm length line, incline at an angle of minus 150 degrees, and then complete the rectangle. So now the rectangle is over. How do we identify the points? So on this 80 mm line, I've got the 2 points, which is symmetric about this also. And the end point here is nothing but the midpoint of this line. So that is the location of the endpoint. So this point and this point can be located as the midpoint of these two lines of length 69.28 mm. And here I need to measure this. So let me go for the distance between. So this point and this point, if I measure, I'll be getting the distance as 20 mm. So from here 20 and from here 20, I'll be getting these 2 points. So let me just confirm this distance also, which is equal to 20 mm. So now let me just mark those points on the 80 mm side. So 20 here, followed by a line of length 20 here. So in the isometric sheet, first you will be drawing 8 boxes and then approximately 7 boxes here because you cannot mark 69.28, and then you will be marking 2 boxes on the 80 side. So totally 4 lines will be drawing for 20 so that you get these 4 points: 1, 2, 3, 4. 5 and 6 are nothing but the midpoint of these lines. So now let me select the line of color black and thickness 0.50. So the midpoint of this to the end point here, and to the end point here, midpoint here, end point here, end point here, and then the midpoint here. So with this I complete the hexagon. So this is how I draw the hexagon. So now let me again select the line of thickness 0.13 and select the blue color, so that I'm going to join these points and get the midpoint of this rectangle that I've drawn. So from the midpoint, I need to draw the axis of the prism, which is measuring 60 as seen in the orthographic projection. So this is the height of the prism. So now I need to replicate the same thing here. So instead of constructing it again, what we can do is, let me select this entire construction, that is the hexagon along with the rectangle that we have constructed. Select all the edges of the hexagon and as well as the uh, rectangle, and then select this line also. Go for the move option, ensure the copy is on. So keeping this point, that is the center point, as the reference, place this center point on the end point of this 60 line. So in the isometric sheet you will be drawing a line of length 60 that is iso 60, and then from each side will be measuring the half distance, that is 69.28 by 2 and 69.28 by 2, and from these endpoints you'll draw 40 and complete the line of length 80 and similarly from here you'll be drawing 40 and 40 and at the end point you'll be taking 69.28 by 2 and 69.28 by 2 here. So this is how you'll be completing the rectangle and the hexagon again on the top plane. So now let me go for the line option again. Select the line of color black, thickness 0.50, and let me just connect the end points so that I get the hexagonal prism in the orthographic projections. So these are the endpoints that I'm going to connect. So this is how the hexagonal prism can be constructed in the isometric sheet. Cone. So the cone has to rest on the top face of this hexagonal prism. And here I need to construct a square of 40 cross 40 on which I can draw the circular base of the cone. So for that, let me just change the color to green and select a line of thickness 0.13. So I do know that the square is measuring 40 so from the midpoint here, let me draw a line of length 20 at an angle of minus 30 degrees, and then the same procedure here, a line of length 20 at an angle of 150. Then again from here, a line of length 20 at an angle of 30 degrees. Similarly from here, a line of length 20 at an angle of minus 150 degrees. So I've got the end points. So from which again I'll be completing the square. So 20 at an angle of 150. From here 40 at an angle of 30 degrees. And similarly here, let me draw a line of length 40 at an angle of minus 30 degrees, and from here draw a line of length 40 at an angle of minus 150 and close this square. So here I need to draw the base circle of the cone. So let me complete the procedure by using the 4-point center method. So from this corner, I'm going to join the end point of the midpoint of this edge, and from this corner, I'm going to join the midpoint of this edge. Similarly, from this corner, midpoint of this edge, from this corner, the midpoint of this edge. So I've got the two centers, center 1 and center 2. And in order to get the center 3 and 4, I'm going to join this diagonal of the square. So that is why I'm using different color lines here. So you should not get confused between the diagonals of the rectangle which was used to construct the hexagon, and the diagonal of the square, which is used to construct the square. So the point of intersection is C3, and this point of intersection is C4. So you have to be very careful when you're constructing the circle. So select a line of thickness 0.13, 0.50, color is black, and go for arc by center point. So this is the first point, and this is the second point, and let me complete drawing the circle, the arc. So from this point to this point. So this is the first arc, so from center 1, and this is center 2. From here till here, let me just sweep an arc. So this is the second arc, and then from the point of intersection here, the green lines. So from here till here, let me just sweep an arc. So from here, from this point, so complete the arc. So C3 arc is over. Now let us proceed towards constructing the arc from C4. So this is the point C4, point of intersection. This is the radii of the arc, and now sweep the arc. So with this, we complete the construction of the circle whose diameter is 40 mm and forms the base of the cone. And also we need to draw the cone now. So select a line of thickness 0.13 and select the center point of the square, which is nothing but the center point of this rectangle. So that is the common center point. So from here, draw ISO 50 in the isometric sheet, but here let me draw 50 to the true scale because the entire combination is going to be converted later into the ISO scale. So now let me select line of thickness 0.50. From the end point, draw a line such that it is made as a tangent to the circle. Again, from the end point of this axis line, draw a line such that it becomes tangent to the circle. So you get this symbol of tangent. So you can complete the cone now. So this forms the construction. So let me just select this and make the edges of thickness 0.13 for those which are invisible. So these are the invisible edges of the hexagon prism. Convert that to 0.13. So you'll be able to see this face, and this face, and these edges will not be seen. Similarly, inside the cone, let me select the split option. Let me select this entire arc and split the arc at this point. Similarly, select this entire arc and split the arc at this point. So you get this as separate entities now. So this entire arc and this part of the arc, convert that to 0.13. Similarly, this portion of the prism will not be visible, which will be overlapped by the cone. So again, go for split, select the entire line and split it here. Similarly, select this entire line and split it at this point of intersection. So this is a different part of the line now. So convert that to 0.13. So this is how you complete the isometric projection of the combination of the solids. So this is So now we have completed the demarking of the invisible edges. So now select the entire combination of the solids and convert that into the ISO scale. So ensure that everything is selected. Now go for the scale option. Reduce the scale from 1 to 0.816, and then ensure the copy is off and place this here. So this is the actual isometric projection of the combination of the solids. So this is the orthographic projection, and this is the isometric projection. So you can just go for the angle between and show the angle between this and this, which is equal to 30 degrees. Similarly, this and this is 30 degrees. So this rectangle is constructed here, the hexagon is constructed, followed by ISO height of 60 mm, and then repeat the construction of the hexagon, connect the parallel edges, and then on the base construct a square of 40 cross 40, construct the circle of diameter 40, and from the center point of the top face draw the ISO line of 50 mm, and from the end point draw the line such that it becomes tangent to the circle, and then highlight the edges which are visible to the observer. So this is how you complete the isometric projection of the combination of these two solids. Thank you all for watching.